In this video, we're going to look at graduated annuities. So the difference between this annuity, graduated annuity, and the previous annuity is that in the previous problem, in the regular annuity problem, let's look at problem number 2. Ellen is 35 years old and she is saving $10,000 per year into her retirement account. So she keeps saving $10,000 every year, even though her salary keeps increasing year after year. Whereas in the graduated annuity problem, Ellen is starting with the same $10,000. However, as her salary increases, she will be contributing more towards her retirement. So she is contributing to her retirement by 5% more every year. So this is the main difference. We call it growing annuity, also called graduated annuity. To solve this problem, unlike the annuities which we have seen before, we have annuity functions in Excel, and we also have these annuity formulas. For graduated annuities, there is no direct Excel function. So we have to extend these formulas. So we have to extend this annuity formula, and then we derive the graduated annuity problem. Present value of graduated annuity is, it looks little similar to this equation here. However, the main difference is, in addition to R, you also will see G, or the growth of, so here you will see the growth of her payment increases. So in this equation here, you see G, in this case, is 5% per year, and then R, which is as usual 10% per year, as in previous problems. Okay, so we have to use this formula, and there is no Excel built-in function. And once you have the formula, we can write our own VBA function to solve this. So now let's open the template. This is the graduated annuity formula. So here, this is R, of the rate of return. Then this one is G, growth of her formula that we are looking for is this formula. This is the future value of a growing annuity. Let me try to implement this formula. Okay, this is the equation. Okay, you can see the equation here as well as here. The future value of growing annuity is equal to payment over R minus G multiplied by 1 plus R to the power of N minus 1 plus G to the power of N. Okay, so now once you have this value, you can implement the same using a VBA function, and that's what I will do next. So this is the VBA function. Future value of a growing annuity is equal to the same formula that you see in our lecture note. Okay, now this is the same formula as you see here, and let's try to use this future value of a growing. As soon as you type FE, you will see FEGA. Double click on FX, and it asks you for inputs. N is 30, R is 10%, G is 5%, and the payment is 10,000. Okay, click OK, and you get the same answer. To remind you, in the previous example, Ellen, when she was contributing the same amount, her future value was $1.6 million. Okay, that is what we had before. It was $1.644 million here, whereas when she is increasing her contributions, by 5% every year. Now she is saving more, so as a result she will have, instead of $1.64 million, she will have $2.625 million when she retires. Okay, that is the end of this graduated annuity. I will stop here.